So this is the cumulative volume. I hope that you can see my handwriting. And then the x-axis is the time. Okay. So you have the data from your fourth column and also your first column. So the first column data is on the x-axis. Okay, I can't really refer to the book, but I hope you understand. The first column data is your x-axis. We're starting with 12 o'clock at midnight until it should be at 12 o'clock at also midnight. Okay, also midnight, another midnight. Basically, it's a day. Okay, so this is the first column data. And the cumulative data or the cumulative data is at the y-axis. Okay, so if you plot the graph, the cumulative data, you will see this kind of curve. Right, so how do we obtain the volume for equalizing demand? If you remember the Microsoft Word that I showed to you just now, so we would like to find out the equalizing demand volume. So what you need to do, since since the pump, okay, if you look at your on page 75, it says that the total storage capacity required for equalizing demand for a continuous 24-hour pumping rate. Well, that means what they are trying to say, the pump will be on continuously for 24 hours. Okay, that means the pump is on for 24 hours. Okay, so if you can remember, okay, the pump is always being pumped at the constant rate, and that's why we have a very constant or very straight line. Okay, it's by being pumped at a constant rate. So the pumping rate is actually the gradient of this line. Okay, I'm not going to draw any gradient yet because it's going to look very messy. Now, okay, let's focus on how to obtain the equalizing demand. What you need to do is for you to draw a tangent like that. One tangent at the minimum point, and the other tangent, assuming that this is does not look like that. Okay, it looks probably a bit high. Okay, the graph is like this. So another tangent at the you have to draw two tangent of line like that. Okay. So it's a bit longer. Okay, we choose at any time that you like. Okay. Let's say this is 12 o'clock at midnight. This is probably at 12. Okay, I don't know. Okay. This is at 12 at in the afternoon, and this is 12 at midnight. So you choose any time that you like. So probably this time. So at 12 o'clock, you try to connect it to our first tangent, and then read this volume over here. Okay, let's say volume A, and then we go straight to another until it meets the line for the second tangent. And then the volume there will be B. Okay. Right. The volume for the equalizing demand is basically this. B minus A. That is the volume for equalizing demand. When the pump is on for 24 hours. Let me repeat. When the pump is on for 24 hours, so how do you obtain the volume of equalizing demand? So you need to draw two tangents, one at the minimum and the other one at the maximum, and then just pick any time that you like. Okay, let's say you pick at 12 o'clock. So you can see where it meets at the first tangent. So it's at volume A, and then it has to go to the second point, or basically we find out the intersection at the second tangent, and we obtain the volume it to be B. So our volume for equalizing demand is B minus A. Can you see my slide now?
Yes.
Okay, that's great. Okay, see, this is the real plot of the data, of the cumulative data, and also the time. So I say that we have to draw two tangents like that. So pick up at any time that they like. For this example, they pick the data at 4 o'clock. So we need to find out what is this point and what is the other point. So let's do that. Okay. Oh, by the way, the pumping rate is 31 liter per second. Okay, that is actually the same value shown here. Okay, so basically if you do the average of this, okay, which is 31 liter per second. Okay? The average of pumping rate at every hour, okay, then this is actually the pumping rate. Alright, so we look at the volume. At the maximum, this one is 1900 meter cube. And then at at another point, at the minimum tangent, okay, we can see that the value is 1400 meter cube. So 1900 minus 1400 is actually equal to 500 meter cube. Okay, 500 meter cube. So let's write it down. Okay, instead of something that you don't know. And this one is 1900 minus 1900, is it? I can't remember. Yeah, 1900 minus 1400 meter cube. And that will be the value that you have to find out. And I think this is 500 plus that. So you should be getting it to be 5 plus 684. That means 1180.4, okay, meter cube. And that is something that you have to write on the second blank. Okay, that means 500 plus 684 is equal to 1180.4. Again, may I request everyone to switch off their microphone because it can contribute to the noise, the sound in my lecture. Okay, I would appreciate very much if you can do that. Now, the last part, the total storage capacity required for an 8-hour pumping period plus the fire reserve. Okay, now for the second case, they don't switch on the pump for 24 hours. Now they only switch on the pump for 8 hours only. Okay, so that is the difference between the second part and also the third part. The fire reserve is still the same. It's still 684, so we do not have problems on that. Okay, but now for the second part of the question, they only switch on for 8 hours. Right, what it means, okay, instead of pumping the water for 24 hours, okay, and that's why we have this pumping rate as 31 liter per second. Now, they will only switch on the pump for 8 hours. Okay, that means they're starting the pump from 12 o'clock at night until 8 o'clock. So what it means, between these 8 hours, they've got to pump really, really quickly. Okay, so that by the end of 8 hours, the reservoir, we have already got a volume of this amount of water, the cumulative amount of water. Okay, so if they're on for 24 hours, they can pump quite relaxingly. I don't know whether there is a word of that, okay, because it's always being switched on and the maximum value is there. Okay, let's say the maximum value is, okay, 2685, and not let's say, this is the real value. Okay, the maximum value is 2685 meter cube. Okay, that means for this 24 hours, they've got to pump really, really quickly so that the water, by 8 o'clock in the morning, the storage reservoir has already got this amount of water, 2685, okay? That can supply this amount of water. Okay. So how much water, what is the volume for that needed for that 8 hours? So how do we do that? Is by obtaining this value, 2865, minus with the volume at 8 o'clock, which is 582 meter cube. You can obtain it from your table, okay? So the maximum value is 2685, and the amount of water at 8 o'clock is 582 meter cube. So you have to minus this value, 2685 minus 582. Okay, so that is the equalizing demand when we start the pump for 8 hours. Okay. So basically that is the 2103. This is the equalizing demand. This is for the fire demand. So you add them together, then you will get the value to be 2783.4 meter cubes. Okay.